Hello student, today we are going to discuss our next rearrangement, that is the Arndt-Eistert rearrangement. Let me first discuss the principle. So here it is a rearrangement. It is a rearrangement in which an acid is converted to its higher next homologue. Acid, or we can say that acid derivatives. Acid derivatives means it may be itself acid, it may be amide, it may be ester. Right? Let me take one simple example. Suppose we are starting the Arndt-Eistert reaction with the acetic acid. So by this reaction, this acetic acid is converted to CH3, CH2, COOH, 3 carbon containing carboxylic acid, which is known as propanoic acid. So here one CH2 is added, right? So it is known as homologue. For example, ethane, and then propane, butane. So all these are known as homologue because they are differ in one CH2 unit. That's why they are known as homologue, right? So the simple example is acetic acid is converted to propanoic acid, is known as Arndt-Eistert reaction. If we discuss the reaction part, so let me take one simple example. For example, benzoic acid. First it reacts with the SOCl2, which is known as thionyl chloride, SOCl2. So acid on react with the SOCl2, first converted to the benzoyl chloride, which on react with the diazomethane, CH2 minus N2 plus diazomethane. This is known as diazomethane. Now the intermediate form in this reaction is this one. Here C double bond O, CH2 N2, right? CH2 N2, which on react with the silver oxide. So it gives 3 product. First one may be acid itself, so one CH2 is more than the starting material. Second may be ester, CH2 COO R dash. Here R dash may be any alkyl group or aryl group, or it gives amide, CH2 CONH2, right? So if we are adding the water, it gives acid. If we are adding any alcohol, it gives ester, and if we are adding the ammonia, then it gives the amide. So this is the reaction part. Acid converted to acid chloride, which on react with the diazomethane, it gives one intermediate. Now remember thing is that here ketene form as a intermediate. So if anyone asks you that in Arndt-Eistert reaction which intermediate is formed, so the answer is ketene, right? The mechanism of the reaction is the first acid is converted to its acid chloride. Let me take R, means we are dealing with the general reaction mechanism. If it react with the SOCl2, so hydrogen from here, Cl from here. So first removal of HCl gas, second one SO and O, removal of SO2 gas, and the product is acid chloride. So general name of this molecule is acyl chloride. It is known as acyl. RCO functionality is known as acyl group, right? Okay, now the important functionality in this reaction is this one, diazomethane. Now there are two functions of diazomethane. First one, it acts as a nucleophile or it may act as a base. So in this reaction, diazomethane acts as a nucleophile as well as base. Diazomethane acts as a nucleophile as well as base. So how we are going to define in which step it acts as a nucleophile or it acts as a base. So the first thing is that here carbonyl carbon is electron deficient. So one is electron deficient, means nucleophile can easily attack on this carbon. One is leaving group, Cl minus halogen best leaving group. So there are three conditions, डोनेट करने वाला है, एक्सेप्ट करने वाला है और निकलने वाला भी है. दैट मीन्स in this step this one act as a nucleophile. So first one, this negative charge of diazomethane attack on this electron deficient carbonyl carbon, right? So now being more electronegative oxygen, it attract the bonding electron pair towards itself. So the first case is the RCl as it is, here O minus, and this carbon is attached with the CH2N2 plus. Right? So here diazomethane is act as a nucleophile. Again, as we discussed that this negative charge participate in the bonding. Chlorine best leaving group leave from the molecule with bonding pair of electron. So we can say that here Cl remove as a Cl minus. So the next step is RC double bond O CH2 N2 plus. So this is the important things. So here diazomethane act as a nucleophile. Clear? Now as we know that if during the mechanism any stable molecule is released, then always do that. Means here R is transfer from carbonyl carbon to this diazomethane containing carbon. Why it is transfer from this carbon to this carbon? So to remove the nitrogen as a stable molecule, because here nitrogen is positively charged. If this nitrogen attract the bonding electron pair, then it remove from the molecule as a N2 stable molecule. Right? So before that we can say that there is some driving forces required. So what type of driving force? So now here CH2 minus and N2 plus, that means diazomethane now act as a base. What is the role of base? To abstract the proton. So this CH2 is active. Why it is active? Because it contains the carbonyl group. Carbonyl group act as an electron withdrawing group. That's why this CH2 act as a active methylene group. This is act as a active methylene group. So this diazomethane abstract the proton from this carbon. If it release the H plus, then it contain the negative charge. Right? So first thing is that this bond transfer to here, R transfer to here, and this nitrogen removed from the molecule as a N2 minus. N2 as a stable molecule. Clear? So here negative charge act as a driving force to transfer the R group from carbonyl carbon to this carbon and to remove the N2 stable molecule. So now the final product is R, which is now attached with this carbon. Here removal of H plus, so it now having only one hydrogen. Here carbonyl carbon and this carbon was single bonded, but it is now double bonded. This carbon attached with the double bond O, and this functionality is known as ketene. Right? Now the product, which type of product is formed, it may be ester, amide or acid, depend on here. Suppose if we are adding water molecule, so now water contain H plus and OH minus, so breaking of this bond, one side H, another side OH. So the first case is the RCH2 COOH. COOH as it is, one OH is there, so it contains the homologue of carboxylic acid. Means here one carbon is more than the starting material. Here is one carbon, here is the two carbon. Suppose we are adding the ammonia. Same thing, breaking of one bond, one side H, another side NH2. So the final product is RCH2 COOH as it is, and now it attached with the amide, NH2 group. So the product is amide. In the third case, if we are adding the alcohol, right? Suppose R-OH is added in this reaction during the reaction. So one side H, another side RO part. Because in case of the alcohol, suppose we take the methanol. So CH3O minus alkoxide ion and H plus is the ionic form. In case of the alcohol, RO minus alkoxide. General name of this molecule is alkoxide. So one side is RO minus and the another side is H plus. So the final product is RCH2 CO as it is, and it attaches with the OR dash. So either it may be ester, it may be amide, or it may be acid, depending on the type of this one. Clear? So this is the complete mechanism of Arndt Eistert reaction. The first case, reaction with the SOCl2, it gives acyl chloride. After that, it reacts with the diazomethane, where diazomethane acts as a nucleophile, so it gives this intermediate product. After that, diazomethane acts as a base, abstract the proton, which is act as a driving force. This bond transfer to here, R group transfer from carbonyl carbon to this carbon. So this shift is known as anionic shift. As we discussed in earlier reactions, this shift is anionic shift because R is transferred from this carbon to this carbon with bonding electron pair. That's why. And why this type of rearrangement is possible? To remove the nitrogen as a stable molecule. So first ketene is formed. Later on, if we added the water molecule, it gives acid. If we are adding the ammonia, it gives amide. And if we are adding the alcohol, it gives ester. Clear? Okay, let me take some examples. Suppose the first one we are going to discuss is the cyclohexene type derivatives. Right? Suppose here mention that you are adding diazomethane plus you are adding the water. So on the basis of water, you identify that the final product should be acid. So here carbon 1, carbon 2, right? So as we know that in Arndt Eistert reaction, one more CH2 is there. So the final product is this one remaining as it is. Here one carbon as it is, one more carbon is added, and the final product is COOH. Why COOH? Because we are adding the water molecule over here, right? We are not going in the depth of the mechanism as we already discussed the mechanism. That's why we give directly product. In the product you have to add one more CH2 here. Here is 2 carbon. In starting material there are 2 carbon. In final product there are 3 carbon atom. Let me take one more example. Suppose this one. So first one, as per the mechanism, react with the SOCl2, then it react with the diazomethane, right? And the third one, let me take one alcohol. So on the basis of this one, you just identify that the product should be ester. So now the final product is one CH2 is more than the product, than the reactant, and ester is the functionality, because here we are adding the CH3OH. So here CH3O, H is attached to here, right? Most important thing is that you have to remember that here ketene is formed as the intermediate. Let me take one more example. Suppose orthonitrobenzoic acid is the starting material. It reacts with the SOCl2, then diazomethane, and then lastly we are adding the ammonia. So the probable product is here NO2 as it is. Here one carbon, we are adding the one more CH2. Ready? And the final product is amide. How you define that? On the basis of this reagent. If you are adding the ammonia, then the final product is amide, COONH2. Clear? Suppose we are taking the benzaldehyde. So suppose you have given the reaction condition. First one react with the KMnO4, second one react with the SOCl2, third one react with the diazomethane, CH2 minus N2 plus, fourth one react with the water, fifth one react with the CO2H plus. Now you have to give me the final product over here. Clear? So this is the Arndt Eistert reaction.